So here is a map of digital elevation models house control. I clipped it from what I gave to you because it's to reduce the processing time when the digital elevation model is higher or larger, covers large area, and with the higher resolution, every cell the computation will be carried out based on every cell, and then that will take time and it will be complex the processes. And now let's see how we can do with the fill. So in the process for doing fill, as you can see, is here, and then it does this one. So look this one, 3 3. This is an input for map for fill sinks, and then consider this is the elevation map. Every grid has this elevation, so you can see this one clearly. And then there is 3 3 3 3 4 4 4 6 5 5. So you can see 2, and then these cells or the values of these cells having this elevation doesn't have any place to go because I'm based on the flow of the flowing gap of water. It flows from the highest to the steepest one. I mean from the steepest to the downhill. So I mean this would be considered as a hill. It doesn't go toward this one because this one is 4, so this one is 4, and then this one is 3. So 2 cannot flow to any direction. Assume that 2 is the elevation and 3 is the elevation 2. So now this would be considered as elevation. And then fill does what? It will take the smallest of the surrounding cell rather than 2. Which one is the smallest? 3 is the smallest. And then it fills provided or assigns 3 for each one, the smallest elevation, so that it can just smooth the depression for the second step, that is for flow direction. So let's do that one. Spatial analysis, and then hydrology is here, and fill. So this is a rastered map that we are filling, and then I can say click OK. So here is the fill. So I'm going to use the fill for flow direction, not the digital elevation model, because I mean it has no any depressions, so I can have every flow directions based on the field depressions. So this is the hydrology group, as I've told you. This is the elevation map. It drains from the higher to the steepest one, you can see here, and then you can see this one too. So for this one, you can see that 6 7 can drain to this direction, to this direction, and to this direction. So based on the slope, you can see the slope is 0.45, and this for calculation is this one. So it assigns to the steepest slope, to the steepest direction, to the steepest direction. So which way is better for the, I mean this cell to flow? Which way is that, down or to this way or to this way? Which way is better? To this one or to this one? I mean look at the slope. These are higher slopes than this one in calculation. So I mean it drains to for this slope than this slope. So it drains to this one. So it assumes what? The steepest slope for flowing. And then the next procedure is flow direction. We have used field, and then you have seen that the assumption of field is based on the steepest slope or the depressions, and then now to the flow direction, the second process in hydrology or basins. So what does it mean? The 8 direction or 4-point algorithm. It uses the GIS uses the 4-point or 8 direction algorithm and assigns a flow direction code to each cell based on the steepest downhill slope as defined by digital elevation model. The flow direction code indicates the cell out of the 8 neighbors. So these are the 8 codes that GIS is using based on the flow direction of each cell. So here it is 1, 2, 8, 16, 32, 64, and 121. These are the numbers or the digits assigned by a GIS by itself software. So this is called 8 direction 4-point model. So you can see that assume that this is a single cell. This is a cell, any cell. And then if the flow direction is twice this direction, it will take what? It will be assigned by 128. And if this cell, based on the slope or the elevation, is flowing to this direction, it will take what? This cell will take what? 1, based on the flow direction algorithm. And take this cell and this one cell, any cell that you are interested. If the flow direction of this cell, based on this calculation, is towards this one, down, it will take what? 4. That is the algorithm, D8 algorithm for flow direction computation in GIS. And then if it is towards this direction, if the flow is towards this direction, it will take what? 32. This will be assigned 32 in GIS for flow direction code. And take this one too. Take this one. Take this one. I mean, the first thing that you have to do is determine the flow direction for this cell. Is this cell flowing towards this one? Black. The first thing for take this cell, like this, the previous one, to determine the flow direction code for this cell. Is this flowing to this direction? Determine first whether it flows to this direction or this direction. And then for determining this one, you have to use what? This one. This one. And then if it flows to this direction, what does it take? Take this one. When this one is flowing to this direction, it will take what? 2. And now it's assumed that this cell is flowing to this direction. And then we can assign that this flow will take 2. And then take this cell. Let's do this cell. I might ask you in your exam this one. I might ask you to fill this chart by giving the elevation. And then you have to calculate and then fill it. 47. This is the elevation map. It might be in feet or in meter. Assume that is in meter for any area. And then for this direction, estimate to which way this flow is, this cell is flowing. I mean to this direction, to this direction, to this direction, or to this direction. Probably it might flow to this direction. And then the only thing that you can check is it's not because the cell has a smallest elevation, but we need to do this calculation, the slope, the steepest slope. So if it says what? This one, I think 1, 2, 3. 1, 2, 3. So this is indicating that the flow direction is towards this one. This one. So 21 rather than 12. So the first thing that you have to see is take the cell and calculate the slope to every direction. Calculate the slope to every direction, and then consider that if you get the slowest, I mean the highest slope, that would be the flow direction for that cell, and then give the result based on these directions. Now, when we are assigning a flow direction for 47, we are just providing 47 here. This is 47. And then if it flows to this direction, we are assigning 1 for 47. That is this one. Good to know? So this is how you can assign the flow direction. So you might be puzzled that if you are choosing the flow direction is towards the smallest elevation size of that cell, you are wrong. So you have to calculate the slope and when provide what? These codes. And then these codes are largely dependent on this one. Keep. 47 minus 48 divided by, you can draw the triangle actually. This side is what? vertical increase and horizontal increase. So you can use the slope for this one. I think this one is like 30, direction of 30, and then this one is what? 67 minus 52. No, this is a cell size actually. This is the cell size, and then the cell size means the distance from this one to this one is, this is a Pythagorean, 30 and radical 2, and then subtract them. So the cell size has to be given. So for this one, look, this one, the slope 37, this one 67 minus 42, that means the elevation difference divided by cell size will take, and then here, because the cell size is, this is the center and then this is the center, from center to center is, I mean that's the cell size, and then we take 30. Had it been the case from this one to this one, the end it would be 60, but these values are representing, assuming that the elevations representing are the center ones, and from this one to this one is 30. We can calculate this one and as an example. Okay, let me take this one. Okay, 47. Okay, 47 minus 21. 47 minus 12. So forget the remaining ones. We have to choose from this one for 47. 22, 21, 12, 14. The first thing, I mean, the best thing is you have to choose the smallest size cells first and then calculate the slope for all of them. And then the higher slope will be the direction in which that cell will uh, flow. 47 and 21, 47 and 20, I think 12, 47 and 22. This one 22, 47 and 34. 47 minus 22. 47 minus 34. Assume that this is a dividend divided by, and this is a assume that this is x and this is y. Okay, for 47 and 21, this one I think probably this would be 30, the horizontal one. For this one, 13 radical 2 times the square root of 2 square root. And for 25 to 25, is there 25? That means 22 towards 22. That's again the same. And for towards 34, that's again the same. Let's see the slope. Hmm? 34 bro. ايش عندي a minute. የትኛው አልሽኝ? 47, 34. 47 is there, 30 you're right. It's straight. Look, this is a straight for 34. We are choosing the smallest cells from 47. The smaller size of the smaller elevation than 47 first. 34, 12, 21, 22. So for this one, the length would be like, take the Pythagorean theorem so that it will be 13 to radical 2, and then for this one is 13, and then for this one is 13 radical 2, for this one is 13, assuming that the cell size is 13. So now let's drag. So which one is the highest slope? This one, 87. And then it does mean what? The 47 is flowing towards this slope direction. So where is that? From 47 to 21. So let's see this one. And then it is the same, 47 to 21. So when the flow direction is in horizontal direction, that means from the cell towards the east, it will be assigned what? It will be assigned with number 1 to this direction. So 47 is now flowing towards 21, and then the flow direction algorithm will assign 1 for 47 elevation, 1 for 47, which is here. So you can do in this way. Is it clear for flow direction? I mean, the only thing that you can do is take every cell, and from each cell consider the lowest elevations first. For this cell, what are the lowest elevation for the surrounding cells? This one is the lowest, and this one is the lowest, and this one is the lowest, and this one is the lowest. So we have to compute the slope from this one to this one, and from to this one to this one. So while we are computing for this one to this direction, is 68 minus 61 divided by the cell resolution. And for this one, 68 minus 58 divided by the cell resolution, square root of 2, because and the distance from this one to this one is the Pythagorean, or this square plus this square. And because they are the same, it takes quadratical sense. And then for this one is 68 minus 64 divided by the cell resolution. And then the direction of flow is to the steepest slope. That means towards the higher slope for this one. So choose which elevation difference profile has brought the highest elevation. If this one has brought it, I mean, if this one is, so the flow direction to be from this direction to this direction. And then what does it mean in D8 algorithm of GIS? So if any cell is flowing towards the east direction, that means to this direction, that cell will be assigned number 1 in GIS. So this will take number 1 in GIS if it flows towards the direction. Now it has 2. Automatically, if it has 2, it means that the flow direction has the steepest slope towards this direction. So slope direction has towards this direction. And then we can cross check it. So this is, we have only the elevation map of the grids, and then GIS will assign flow direction codes by using D8 or flow A algorithm. And now let's see how we can do in GIS. So the next is flow direction. So the flow direction is, I think, field we are using, and then now this is optional. We can click OK, and then it will give us the flow direction. And then it gives the flow direction, gives the flow direction codes for every cell. So here is, it assigns from 1 to 128. That means this one, 1, 2, 4, 8, 16, 32, 64, and 128. So you can open and look at one of the things, any one of the cell. I mean, the identification is by color. You can assign, you can look at it. For instance, this one is 16. You can see it assigned 16. That means for this one is like, for this one is again 32. It means what for 32? For 32, that's the flow direction. So this cell is 32. So the flow direction for this cell is towards this direction. And this one is again 32, and the flow direction is to this direction. This direction. So these cells have the flow direction towards this direction. based on the flow direction assignment here. You can see that. If any cell is flowing towards this direction, so it will take 32. So and then we have defined this is 32, this cell, the cell size is 32, and then the flow direction for this cell is towards this direction, towards this direction. And this is also another cell, it flows towards this direction. And this is another cell, it flows this direction. So by doing this one, we are just done with the flow direction. So the next is, I think, flow accumulation. So by doing this one, every cell will have its flow direction, and then it will be connected, and then it will become like a flow network. So they will be assigned, this cell flows towards this direction, and then another flows towards this direction, and this one again might flow to this direction. So they will be connected and provide that a flow network, not a grid, a flow network. So here is a flow direction in JS. So here it says compute the flow direction for the following given elevations. For each of the elevation, you have to compute the flow direction. The first thing that you are computing, this is the elevation map, and you will be given with the data of with cell resolution of 30 meter. I'll give you this one, and then you have to compute it. First, assign D8 algorithm for each cell codes, and then the second is drawing the flow direction for each cell. So two steps: assigning, but after generating a slope for each cell, you have to do what? You have to do, or you have to assign the flow direction codes, and then from flow direction codes, you have to do the flow directions where each cell is draining in direction like this one. So that will be your assignment, and then you will be asked in exam. So the next one is a flow accumulation. So there is a flow direction, and then how much cells, flow accumulation tells based on the flow direction, how much cells are just accumulating to a single cell, how much cells are draining to a single cell by using a support point. Number of cells contributing the flow, and flow accumulation is measure of drainage area in unit grids. That means there is a single cell, and that cell might have what? Upstream or contributing area cells, and then how much are the number of cells contributing to that cell. And then look at this one. This is digital elevation. This is flow network from a dam, and then this is flow accumulation grid. Flow accumulation grid. What does it mean? Zero. Zero indicates what? There is no any cell flowing toward this cell. One. There is one cell flowing toward this cell. And three. There are three cells draining to this cell. And then this you can see that 24. 24 cells are draining towards this cell. So we have a flow direction, and then the number of cells draining to a certain point, we can have what? We can see the stream flow path, or the nature of the stream flow path. And then here is what you can do, and then you can see flow accumulation. Let's do how it works with GIS. Flow accumulation. And then it needs flow direction. This is flow direction. And then there is no anything that we can put. It's optional. This click OK. And then we can see the output like that one. So it's processing, we can proceed till it finishes. So here it is the flow accumulation map, and from flow direction a flow accumulation can be derived. Yes, we did that one. And the accumulated flow for each cell is the number of cells that flows into this particular cells. We have the flow direction, and then from flow direction we can see that the number of cells draining to that cell. So cells with a value 0 have no other cells flowing to them. We have seen that one. If there is no any cell draining to that cell, we can assign 0. And if cells have large number of cells draining into it, you can provide that number of cells. The cells with high accumulated flow count represents streams. So when with cells having large numbers, they are representing the flow, or count represents the streams. So this is the map that we are expecting from the flow direction, flow accumulation. And then similarly, you have to compute flow accumulation for this elevation with cell size 13 meters. So now if we want to define a stream, we can define a stream, but it's not that much important. We can delineate using a flow accumulation. The function is stream definition, and then the argument is the input is flow. From flow accumulation, the next thing is every cell has the number of cells pouring into it. We can define the stream and try to look for the stream networks here. Every cell would have number of cells pouring it, and then this cell, so joining those cells and then creating the streams will be carried out by using the stream delineation. Series processing actually. And then stream links. Linking those streams with the joints and then assigning the grids. And then the outlet. The outlet is the place where we are looking for having our watersheds, like that reservoir. And then we can create the outlets and then delineate from flow accumulation. And then the final one is watershed delineation. So these are the watersheds that we can delineate and found. So let's now here stop and then go to the procedure. So here is a flow accumulation. And then let's see how it works out. In properties, I can name symbology and then classified, and probably I can classify here. This is, let's say, manual. No. So manual, let me make this one to like 3000 or 2000, the maximum number of cells. Okay, and then let me make this one like white, and then this one blue. Apply. Okay, so you can clear this is that when I just zoom in, it comes like these are kind of networks of the stream. So I have the fill, the flow direction, and then the flow accumulation. So if I'm looking for stream link, I can just create stream link. The stream links that we have seen. Flow direction, no, flow accumulation. Stream links, that links those streams. But now for delineation, we can use 3 steps: the fill, the flow direction, and then flow accumulation. From flow accumulation, we can create 4 points, and then from those 4 points, we can use those 4 points as an outlet, and then those outlets can help us to delineate our watershed. And then that outlet should be similar with what we can put, a reservoir, or what you can just estimate our recharge area. So I have an outlet. This outlet, assume this outlet is the area where you will put your reservoir. This is the area where you can put your reservoir. And then I'm creating an outlet, another outlet actually. Let me this one finish. This is not the outlet that I'm using, but it does put or it does lead me to put the 4 points based on this outlet. So I mean, consider that this is an outlet or the concentration point for your reservoir dam location, or for your watershed, water storage or water harvesting structure for water supply location. And then I have to put my 4 points like here, and then I want to delineate my watershed. That means the area that the streams are draining and passing to this concentration point. Yeah, it took time to process this one. So the output, you can see that you can have the catchment area or the so-called watershed area or drainage area. Catchment, drainage, basin area, you can find it. And then the slope of the catchment, how much water drains, and then there's the stream power to know to calculate the stream power. And then you can calculate or you can estimate the longest flow path, and then the average slope. I mean, this is how you can parameterize, and then you can create different hydrological parameters that will use or to estimate your amount of volume of water from the watershed. So this is a stream flow, but I don't need this one actually. So I'm looking for this one. Now I'm going to provide a watershed outlet and then delineate the watershed. For doing this one, I have to create a snapper point. So here is your watershed, I think, and then here is watershed process. I can just create a shape files to indicate these are 4 out pores, and then the point I'm looking for, I'm using for WGS. I'm creating a 4 points. So here there is no any feature attached to this one. I have to create the feature, the 4 point, and then I have to edit it. Outlet 4, yes, and then I have to create the point. The point parallel to this one. I mean it's not on the right part of the stream, on the corner of the stream or the flow accumulation. I have to create on one of the cells, on one of the cells. So I can put actually here, and then let me edit it. I mean I'm looking for that. And the flow accumulation is, or the flow accumulations or the streams which are draining towards this point. So all of the flow accumulations or the streams that are draining to this area will come to this point, and then the area will be delineated by using this outlet. So I have to stop, and then yes. And then the next point is to snap the 4 point. Snap the 4 point means to put exactly on the raster or to rasterize the this outlet, the outlets that I gave it to the what for delineation. Snap 4 point, and then this is the point that I'm looking for, and I'm looking for everyone feature ID, and flow accumulation is the flow accumulation. It means the flow accumulation, and that means that it integrates my outlet with the flow accumulation. I have to say okay. You see, so snap 4 point. This is it. The cell that means so snap 4 point. I give the point, and then So it means that this point that we have to give, that have given for GIS has been changed to cell, a single cell. So that the flow accumulation towards this cell will be would have certain boundary. That boundary will be denoted as a watershed. Now let's provide this watershed. It asks me the flow direction. This is flow direction. Input raster or feature data 4 point. I'll have this snap 4 point. Snap 4.4, and then to take the value field, and then I need my watershed. We will have a definition of watershed using hydrology, NGIS, hydrology, spatial analysis, hydrology. The first thing is field things, flow direction, flow direction, flow accumulation, okay, watershed, outlet, using this outlet, put on the right place where you want to put your outlet or design your reservoir, and then snap 4 point, the 4 point, and this is the input for start 4 point, and then watershed. This is using hydrology spatial. Also, there are methods, another method. You can use ArcSWAT, automatic distribution, and then ArcHydro, hydro step by step. These are the packets. So by using this one, we found our watershed. This is the place where we have the watershed, and then this raster we can convert to polygon if we need. This is the watershed flow, and then you can convert from raster to polygon. I mean, for our analysis we need watershed. So here is our polygon, and now this is the watershed that we have. And then if we are interested, we can use for our interests, especially for, I mean, estimating the recharge, the runoff volume, and etc. And even to know the boundary for our purposes.